maybe we start from Asia country. Probably know Japan and Korea. Japanese student, Korean students, Russian student. Russian, really?
Yeah.
Baruski?
Baruski.
You really from Russia?
That
Which city? Moscow? Okay. You are also from Moscow? No? Oh, from where? Sorry, I don't know that. I'm very bad at the geography of Russia, but welcome. Okay. I have some collaborator in Moscow, Russian Academy of Science. Okay, I have never been to Moscow. I should be there but due to the war, I cannot go there. But I just feel excited to see Russian students here. So, yeah, okay. All right. Okay, and I like Russian music, Tchaikovsky, Rachmaninoff. I like ballet, so Russian is definitely the country I want to visit. Hopefully the war can be finished soon. Okay. Any other Asian country, for example, Vietnam? No, Vietnam? Okay. Malaysia? Singapore? No. Indonesia? Oh, a lot of. Okay. I think it's a majority of the profile here. So Malaysia, no. Singapore, Indonesia, India? No. China? No. So, what else the country in Asia are you guys from? Can you tell me? Are you from Asia? No? Okay, so we finished Asia, and any student from Europe besides Russia? Where are you from? Germany. Okay. Cool. Berlin? No? Where? I don't know that.
Do you know a little bit of soccer? That's big for people.
I'm not a big fan of soccer, sorry. But I'm not a big fan of classical music. If we have good orchestra, maybe I know the city. So I know Berlin, because the Berlin Philharmonic Orchestra. But welcome. So besides Germany, any country from Europe?
Russia is Europe, actually.
Yeah, I know. So I say beside Russia, but you're kind of partial of Asian, partial of Europe. Okay, yeah. Okay, your country is very big. Oh, any country from Europe? No. So we travel to America. Any country from America? Where are you from? I don't know that because you are very far away from me. Oh, Panama? Paraguay. Okay? Paraguay. Besides Paraguay? Honduras. Okay, great. Honduras, Paraguay. Hola, amigo. Any else country? Okay. So, what else? Do we have students from Africa? Okay. So welcome to join the class. So we have friends from many countries. Okay. Excellent. All right. So as I mentioned, the goal today is to introduce chemical engineering. Okay. I don't know how much you know chemical engineering, but this is a kind of introduction. So this is my name. You can call me Wei Hong, Dr. Chang, Professor Chang. But anyway, I just come here to introduce. I'm not a serious professor, so you can have a good talking today. And I'm the professor in our Department of Chemical Engineering. And as I mentioned, my major in college is chemical engineering. In National Taiwan University about 22 years ago. Okay, I was born in 1981. I got admission there, and after can you change it back for me? Yeah, Steve is a good example of why I majored in chemistry, not communication or double E, because I'm really bad at electronics. Okay, so I got my bachelor degree in chemistry. Then after 2 year Army service, I fly to United States for my PhD, again major in chemistry, okay? Then after that, I start my research position in some national institute, and I start my faculty position in 2013, almost 9 years ago. 我觉得它快没电了，所以它会死好。
电视不要。
要不要？你可以帮我去换一下电池。Yeah. So without microphone, is that my voice okay? A little bit short? Yeah, it's okay. Yeah, I tried my best. Okay. Yeah, in China we have qigong. So if you want to your voice louder, you can use qigong. But I'm not practiced with qi, so I try to enlarge my voice using my limit organism in my thought. Okay, so I start my career here as a faculty position 9 years ago. So I meet some students, so they have puzzle and confused what's chemistry, and I try to help students what is chemical engineering from my point of view. Okay. So first, we would like to discuss what is chemical engineering. So from this term, you see two keywords. One is chemical or chemistry, and the other thing is engineering. So these two terms give you some very important factor of chemical engineering. One is chemistry, the other is engineering. So from your first image, you will think about chemical engineering. Actually, it's dealing with a lot of chemistry. Chemistry means a reaction. You have some raw material, you put them in beaker at the right condition, for example, right temperature, right pressure, right concentration, then you can produce something else besides your raw material. Okay, that's a general understanding of chemical reaction. So chemical engineering, no wonder dealing a lot of chemical reaction because we want to produce something. Okay? And another term you will see is engineering. Engineering means that we want to create something new. We want to create something useful, like a car. Okay. So mechanical engineer, they design and build cars, so we can use car. So that means there's some application. Okay. So engineering focuses on how to solve the problem people facing every day. So this means that chemical engineering not only focus on chemistry reaction itself. Instead of that, we want to apply the chemical reaction to be something more useful. Then we can use that useful things to solve the problem. Okay? So that's a good video from YouTube I checked a couple days ago. So this video kind of long, about 14 minutes, but I would like to play video here, then we can watch together and understand what's chemical engineering from their point of view. Okay?
Engineering is defined as an engineering discipline that involves designing processes to transport, transform, and produce materials. Chemical engineers have knowledge.
Okay, let me start over because maybe if too soundly, everybody gets shocked. Okay?
Chemical engineering is defined as an engineering discipline that involves designing processes to transport, transform, and produce materials. Chemical engineers have knowledge of physics, chemistry, biology, and math to design these processes. Now, chemical engineers have a wide range of careers they can go into, which is definitely a perk of this major and what I want to talk about first. So for one, you can go into biotechnology and the pharmaceutical industry, where you design facilities that use enzymes and microorganisms to create new drugs. Companies like Pfizer or Merck are examples of this. You could go into environmental engineering applications in which they try to reduce the volume of pollutants that enter the air, waterways, and soil. Think of catalytic converters on our cars, which need to be designed to minimize the amount of harmful material that is released. Catalytic converters are essentially just small chemical reactors They aim to reduce the amount of harmful substances released by the car. You can also go into semiconductors and electronics, which is actually very big for chemical engineers that lots of people don't realize. Think about companies like IBM and Intel that design and manufacture microchips and other computer parts. You'd think these places would mainly hire electrical or computer engineers, but these places are huge on hiring chemical engineers. To manufacture these microchips, they start with large silicon crystals that are then cut into wafers. Then the transistor architecture is pressed onto this material. The transistor design is left for the electrical or maybe computer engineers, but the framework or foundation and the process that makes it happen is what the chemical engineers do. Overall, there's a lot of chemical design and chemical processes involved in making those chips. You could work on industrial chemicals like detergents, soaps, and cosmetics, like at Procter & Gamble or Johnson & Johnson. Most people don't realize just how much work goes into that one bottle of detergent you get from the store. You can work on food production like at Nestle or Kraft, or wine and other alcoholic beverages like at Budweiser. You can work in petroleum engineering like at an oil refinery that turns crude oil from the earth into gasoline, diesel fuel, heating oil, etc. You can work for companies like Shell or Exxon, which hire a lot of chemical engineers. So while a petroleum engineer may specialize in designing the equipment to extract the crude oil from the earth, chemical engineers may focus more on designing the equipment that implements the chemical reactions which turn the crude oil into something useful like gasoline or diesel oil, as you can see in this picture, which would be found at the refinery shown above. You could work in alternative energy. For example, there's solar cells which involve chemical processes to be designed like the microchips I talked about earlier. Or you can work on fuel cells which convert chemical energy from a fuel into electrical energy. These can be seen in cars, planes, boats, submarines, and more, and you learn how these work and how they are made. And there's even more careers you could get into. Now let's talk about specifically what the chemical engineer does in these fields. Like I said, they make food or alcohol, but how? What exactly do they do? Well, chemical engineers focus mainly on scale-up. This is a term you'll hear a lot if you've done research, as in taking a small reaction and scaling it to happen on a larger scale. This is important and is a main difference between chemical engineers and chemists, which I'll get into later. So maybe a new liquid soap is designed in a lab. That's the small scale, just using typical equipment. So now you have the formula for this new soap. But how are you going to produce large amounts of it in huge reactors, big enough to even fit a person? This is the large scale, because it needs to be shipped out in thousands of bottles. Do you think you just add more chemicals and do everything else the same? That's not how it works, because problems will occur if you do this. So chemical engineers focus mainly on chemical process design, like designing a processing plant, or a big one for them is designing chemical reactors, which is where the large-scale chemical reactions take place. And of course, there's more equipment than what I've shown so far. But let's look at an example of manufacturing beer, which I think is something chemical engineers can do. Well, there are people out there that brew beer at their house, but this is the smaller scale. Chemists or chemistry majors can understand on a deeper level the chemical reactions that take place during this process and look for ways to improve it. But if we look at a company like Budweiser, they have to produce large amounts of beer. So they don't have some home station. They have large reactors that make the beer, and this is where the chemical engineers come in. You can't just take that same at-home formula and make everything bigger. Lots more has to be taken into consideration. So to make that reactor, you have to size it properly. You need to design a cooling jacket, which is a layer of cooling water that surrounds the reactor to maintain the proper temperature, because you don't want it to get too hot. You need to design all the safety components, such as the temperature sensors, the flow sensors, and the control systems that go along with them. If the temperature sensor says it's getting too hot or cold, the control system tells a valve that is letting in steam to open or close based on the temperature. It seems like something an electrical engineer might do, but chemical engineers will see this as well. You'd also have to design the pressure release valves to maintain proper pressure within the reactor. On a small scale, you can use a simple valve, but with a huge tank, there needs to be a very specific pressure release valve. Also on a small scale, you can just pour in materials like the yeast to make the beer. But on a large scale, you have to design the piping that delivers the material, because if you deliver too much too fast, then problems can occur. And this is why you do have to understand chemistry, because you have to know what's going on in the reactor so you can apply the engineering principles to design it safely. how fast the reaction happens has to do with kinetics, which I'll talk about soon. But did you notice something about everything just listed? It's really not directly chemistry related. You have to understand the chemical process going on in the reactor that makes the beer, but there's so much more like the valves, controls, pipes, sizing, etc. that isn't directly chemistry related. And this is where chemical engineering and chemistry are different. A chemist would not be doing everything just listed, as that contains a lot of engineering rather than strictly science. So to be more specific, a chemist or chemistry major learns more about the reactions on a smaller scale and they have a deeper understanding of those reactions. So if you want to be the person who puts on a lab coat and works solely with chemicals, chemical reactions, formulas, etc., then you probably want to major in chemistry or maybe even biochemistry if you want to look at the chemical processes within living organisms. But you would need to get a master's and even consider a PhD. Those are the people who are designing the new types of medicines, gels, detergents, and so on. But then they usually hand off that information to the chemical engineer, who then scales up that process. And they design the plant, the reactors, and so on, where that same chemical reaction will happen, which is why they still need to have an understanding of the chemical reactions. But much more needs to be accounted for. Now, I will say that this isn't always the case, so don't take it as a guarantee. There are chemical engineers who do work in a lab and work on chemical design like a chemist would. But usually they work on more of the large-scale plants and reactors, which involves so much more than just working with chemicals. Now, I want to briefly go over their curriculum. Chemical engineers take all the same calculus classes as pretty much all other engineering disciplines, and they do apply it in their other classes. So yes, chemical engineering does have a good amount of math, even calculus level math, and it is more math intensive than the chemistry curriculum. So that's just something to keep in mind. Now they also take general chemistry, organic chemistry, and most will also take physical chemistry. Each of these take about a year to complete, but schools may differ. And note, these are all chemistry classes. They're not listed as chemical engineering classes. And this is the main similarity in terms of the curriculum between a chemistry major and a chemical engineer and even a biochemistry major. Those majors will take all of these courses. They have the only similarities, but a good amount. In general chemistry, you go more into depth about lots of chemistry concepts such as chemical equations, chemical formulas, atomic structure, etc. The beginning of this class would be similar to high school chemistry, then you learn more topics later on. In organic chemistry, you learn about carbon-containing compounds. This is a lot of applications in drugs and medicine, but in the class you'll learn functional groups, three-dimensional structures of these molecules, organic reactions, and so on. And physical chemistry is where you learn about quantum physics and how it applies to chemistry. So you learn more about the physics of how atoms and molecules behave. This is probably the most math-intensive chemistry class that you would take. One important chemistry concept is kinetics that I talked about earlier, where you understand how fast a reaction will occur. Some universities have this as its own class. So if you have a hypothetical example of converting A and B into C, then this may be the starting concentration on the left. And after some amount of time, you have a different concentration, and in kinetics, the foundation is analyzing the speed at which that reaction occurs or how the molarity changes over time. So the rate at which this happens might be given by some curve of concentration over time, which is not linear as you can see. So for those who have taken calculus, you can see how you might need to use it. Like the derivative or slope at one point can tell you the rate of the reaction at any moment in time. And as you can guess, you'll also get the differential equations. And if you haven't taken calculus yet, don't even worry about this. Just see how kinetics is a very math-based topic, and I just wanted to give a very basic example of how calculus can apply to chemistry. In the real world, a chemist might analyze characteristics of a reaction, then the chemical engineer would take that data and figure out how to design a large-scale reactor where the reaction can occur. So if we think back to the manufacturing of beer on a large scale, I said you have to design the pipes that would add chemicals into the reactor. It all has to be controlled and the liquids need to be applied at the proper rate. If the reaction happens too fast, problems occur, including the reactor possibly blowing up. So hopefully you can see why chemistry is important for chemical engineers, even though they have to focus on many other things. So that was a list of a little bit of the chemistry that you learn. And a lot of these concepts are foundations for what you learn in your chemical engineering courses. But in those courses, although you need to apply some chemistry concepts, you really focus on more engineering topics as well. Like you'll take classes on thermodynamics, fluid mechanics, and heat flow, which a mechanical engineer would see as well. The classes have their similarities, but also their differences as they define the different applications for each major. These are also very math intensive, where you learn the physics about heat moves through materials and how fluids behave in different systems. So like when I talked about the cooling jacket for the chemical reactor, this goes on the outside to maintain the proper temperature, and that's where thermodynamics or heat flow would be important, and understanding how heat will move through the reactor. When it comes to designing the pipes to transport the fluids or chemicals, that's where fluid mechanics comes in. The pipes must be able to sustain the proper pressure and speed the fluids will be moving at. And there are, of course, many other classes that you take in chemical engineering that I'm not going to go into. Now, in the real world, chemical engineers could work on the computer and simulate or model the plant or reactor that they are designing. There is software that even models how liquids will spread throughout a solution as they are being poured in. They could walk around the plant and check on the sensor readings for various reactors to make sure that everything is safe within the area. They can work with other engineers to ensure they are producing enough, that everything is efficient enough, and so on. So as some final thoughts, if you're maybe in high school or early college and you're thinking that you love your chemistry class more than anything, should I do chemistry or chemical engineering, or maybe biochemistry or something else? There really isn't a right answer, but I will say this. Of the chemical engineers who helped with this video and what I've seen online, a common thing that chemical engineers have said is something along the lines of, I like the idea of doing experiments using beakers and test tubes and the chemistry behind that. But what I really want to do is to take that and figure out how to make it on a large scale so that it can go out to consumers or businesses. They enjoyed the chemistry, but that was just one part. They also wanted to learn the engineering principles needed to mass produce whatever it is they were most interested in working on. So just to summarize, remember, if you want to strictly work in a lab and do experiments, then you might want to consider chemistry or even biochemistry. But definitely consider getting a master's or PhD if you want to do the high-level design work. With just a bachelor's, you'll most likely be a lab tech to begin, where you'll be following step-by-step instructions given you by a superior, and it won't be as academically challenging. If you like chemistry but want to figure out ways to produce materials safely and efficiently on a large scale that is also environmentally friendly, then chemical engineering will be right for you. Chemical engineers could work in labs like a chemist does, but it's just less common to find that. And also when it comes to chemical engineering, you really just need a bachelor's degree to be qualified for the majority of entry-level positions, which in the US have a median starting salary of $67,000 per year. It'll be very rare to hear of someone with just a bachelor's in chemistry or biochemistry getting that salary right out of school. Chemical engineering is again extremely broad, and there's a lot that you can go into, and you have to have knowledge of chemistry, but also physics, engineering, fluids, heat flow, controls, and so on. So hopefully you now have a better idea of what chemical engineering is and whether it's the right major for you. If you like this video, don't forget to like and subscribe, and I'll see you all next time.
So hopefully after this video you can have kind of briefly understanding of chemical engineering. But I would say this video just touched maybe briefly understanding, not give you the whole picture of chemical engineering. So again, if you have a question we can discuss later. So let me continue my sharing. So I want to give you my personal understanding of chemical engineering is that chemical engineering, using a simple statement of chemical engineering is that all we want to do for chemi, which is the chemical engineering, is to do mass production of value-add product to make revenue. So you see something is that we want to do mass production. Mass production means that we want to produce things in larger quantity, not just very tiny amount, because we want to make money. And the thing we want to produce should be value added. Value added means we can sell it and make a profit. And the purpose of the whole chemical engineering concept is that by this kind of activity and by this kind of process, we want to make revenue, which means money. Okay, so we are very different than chemists. Chemists, they focus on the discovery of some chemical reaction. then they are happy. They will study the chemical reaction, understanding why, the mechanism, so they are happy. But for chemical engineering, we want to go beyond on that. We want to take that reaction because we want to produce some value-add products, then do mass production so we can sell in larger quantity. And all the purpose is that we want to make revenue. So I would say chemical engineering actually will be chemistry plus economics. So chemical reaction is the core. But the whole major goal of chemical engineering is that we want to focus on more on economics. Chemist people, they don't care about economics. They produce something by discover some chemical reaction, they're using something bigger and tube shaking and adding, then boom, they got a product and they are happy. But they don't care about how to do mass production, they don't care about the market, they don't care about the price, they don't even care about the making revenue. So they don't have the concept of economics. So for chemical engineer, economics concept is very important. So all the missions are around making revenue. Okay? So how to making revenue using a simple schematic illustration here is that you have some raw material, and normally this raw material, they are very low price. For example, corn, starch, you can see that everywhere. Rice, yeah, and some biomass, for example, or even crude oil, or maybe some something very cheap. These are raw material. And we want to design a process. This is a chemical engineering process. We want to design a process to turn this low price raw material into high price product. For example, starch, if you can design a process to convert them into some very special drug. And this special drug, maybe they can kill some critical virus like COVID. If you can find a process to convert the low price raw material into high value add product, that'd be something very cool, right? So that's the mission of chemical engineering. We want to design a process. So chemists, they focus on the reaction. Taking back that example, they use some sugar or starch. I'm just throwing out some example, not exactly the right. So they find that the reaction can turn them into some pharmaceuticals and drugs. And they are happy. They focus on this in the lab. But with chemical engineering, we want to go beyond that. We want to design a process so we can do mass production to turn this low price raw material into high price product. And when we design the process, we need to consider economics. What is economics? The difference between the price here and the price here should be maximized so that you can make more money, right? That's a very simple concept of economics. Your output should be, the price should be as high as possible, and the price of your raw material should be as low as possible, so that the difference will be the money you can make. So this is a whole concept. We want to maximize the revenue here. So you want to use very low price raw material. And also during the process, we need to minimize the cost, because during the process, maybe you need to add some solvent, and maybe you need to heat up by high temperature, and also you need to using some utility like electricity or water and so on. So we want to minimize the cost. So this one and this one, we want to minimize. And the price, we want to maximize. How to maximize the price? For example, you need to do some market survey, and also your performance of your product should be high, and the purity of your product should be as high as possible. So we will do some research to understand how to design and create the chemical engineering process to complete the mission here. And all the key is we want to maximize the revenue. And in the college, you will study a lot of chemical engineering principles. For example, thermodynamics, kinetics, and transfer phenomena, including fluid mechanics, heat transfer, and mass transfer. Also, we need to study a lot of chemistry major, for example, general chemistry, organic chemistry, biochemistry, and even the physical chemistry, and even quantum chemistry, if you have the interest in that. We need to study a lot of chemistry fundamental core, so you can understand how to design the process. Without understanding the chemistry reaction, we cannot design the process. Okay, so this is a kind of a general concept of what's the mission of chemical engineering. So the key is that think about economics. Okay, chemistry plus economics will be the whole concept of chemical engineering. And the key is that we want to make revenue by designing new chemical engineering process. Okay? So I will give you one example. Everybody know what's this?
Egyptian from Egypt.
Yeah, from Egypt. What they are doing now? Making wine, exactly. So making wine, so your raw material is grapes. And your product is wine. So actually they are doing chemical engineering process. So think about the raw material is grape and their product is wine. So this is chemical engineering process. Using their food, using their bodies to squeeze out the juice of grape and by some special enzyme. And during the fermentation, right? Everybody understand there are some sugar, some organics. During the fermentation, we can get alcohol and some special flavor because some aromatic inside the grape. And the right condition, we can get wine with good taste. So this is a very, very simple chemical engineering process about 4,000 or 5,000 years ago. So people are working on chemical engineering for a long time. However, they don't have the concept of mass production. They're just using their feet, right? It's very, very slow output. Okay? So everybody know this? What's this? Any idea? Do you see this Chinese character? 酒. So wine, right? Alcohol. 酒 means alcohol. So these are the 酒 means wine, alcohol. And do you guys see this Chinese character? Maybe it's not clear, but this is a 粮. 粮 is a corn. The Chinese character of corn. Corn? Yeah. So like a rice or other special corn. In Taiwan, we have 高粱酒. So if you like Russian brand, if you like strong alcohol, it's like a vodka. Taiwanese vodka, 高粱酒.
I should try it.
You should try, yeah, definitely you should try. That's the best in Taiwan. So this is another example of very, very old-fashioned chemical engineering in China. So Chinese people use corn as a raw material. By their process, you see they are doing some process. And I'm not kind of understanding their process, right? But you see they are working a lot of different zone process area. So their goal is to convert the corn, the raw material, into wine or alcohol. That's their product. Okay, again, this is another very, very old-fashioned chemical engineering process. So human beings are born to working on chemical engineering process. However, the problem again here is that the throughput is very, very low, right? So whatever Egypt or Chinese people, they are using very traditional manual way to produce wine. So back to now is 21st century. Everybody enjoy alcohol, beer, drinks almost every day. You can go to downstairs convenience store or you can go to the supermarket. You can buy alcohol and liquid very easily. And all kinds of beverage you can purchase from different countries with reasonable price. This is because of modern chemical engineering process. This is the beverage plant in, I believe, in United States. So everybody know Budweiser? It's a beer manufacturing. It's the world's largest beer manufacturer. But think about when I was a student in the United States, American people, they drink almost every day. They have happy hour. Happy hour means that they go to bar and they drink beer with a very low price. Sometimes 1 liter of beer, you want to guess the price? Maybe less than $1. It's cheaper than water. It's cheaper than the bottled water I just purchased downstairs. This one is about half liter, cost me about 20 Taiwan dollars. So think about 1 liter beer, less than $1 US. Now $1 US is about 31 Taiwan dollars. This is cheaper than the water. Okay, so that's how the chemical engineering process can help everybody can enjoy the product. Okay, so this is a very modern chemical engineering process. You see pipes, lines, reactors. It's very modern and very automatic. And the goal is that we want to use low value add raw material to turn them into high value products. And this is just one example. And think about every day when you wake up, when you brush your teeth, the toothpaste, right? When you eat your breakfast, the food you enjoy, including the milk, juice, cheese, bread. And now you're working on your 3C device, using your laptop, using your iPad, all the chips, all the IC inside. And when you finish your work, you will go to bar, the beer. And also when you have the disease, you will go to medical hospital, the drugs, and even the clothes for artificial fiber. And when you go to somewhere by transportation, the gasoline and the electricity, everything we enjoy every day, we cannot get rid of chemical engineering process. So it's everywhere. It's everywhere. As long as we want to convert something from low price to useful things, that's chemical engineering exists. Okay? So think about this, chemistry plus economics. Okay? So I want to share you some possible job market if you get a degree on chemical engineering. This is just one of the examples, not totally 100%, because that will depend on the country and also depends on the job market. So for example, biotechnology, for example, I just mentioned drugs, pharmaceuticals, biomaterial. It's belong to chemical engineering process. And also the second one is chemical products like plastics, also maybe some composite, epoxy, some special chemicals. And the third one is process blind, like a construction. You can also building on some chemical engineering process in plant. And third one is pharmaceutical. This one is water. So actually water industry involve a lot of separation because you want to get rid of the dust and impurity. That is also belong to chemical engineering process. No wonder food beverage and environmental protection, energy, oil, gas, even the nuclear plant is also chemical engineering process. You can also do a lot of manufacturing design and also the material every day we are using, papers, metals. You can working as a professor or teacher in academics. And the most important thing right now in Taiwan will be semiconductor IT, because we have a lot of well-established semiconductor companies like a TSMC. So they hire a lot of chemical engineers because they want to produce a lot of chips and ICs and others. Let me give you one example of the semiconductor process. So everybody know this is a process. This is a microprocess inside your laptop and your smartphone, right? So this is so tiny, but maybe you don't know how to produce them. So this is just kind of general process flow of how to make chips. Start from your silicon wafer, and you start to work on so many processes. I will not detail to talk about the process, Then you start from this is a wafer, okay? Then you working on so many chemical engineering process. Finally, you can get this IC and electronic chips and install inside the 3D device now you are using. This is a very typical chemical engineering process. Okay, so EE engineer, they focus on the design of the circuits, but how to make it out, how to do the manufacturing, actually is chemical engineering process. Okay, for my understanding, maybe more than 10,000 or even more chemical engineering process if you want to start from the raw material, which is a wafer here, to the final product. But think about the device now you are using. Actually, there are more than 10,000 or even more process. Okay. So this is a very good one example of how chemical engineering can contribute in semiconductor industry. Okay, another thing I want to share is that in Taiwan, we have very strong electronic and semiconductor. So I do a quick Google survey this morning. This is a annually salary for big company in Taiwan. Okay, so the top one, Hongjun. This is the number of the stock market. So if you are doing some investigation, you can use this code to buy their stock share. So Hongjun actually is an electronics company. Lianyou also electronic company. Lianfake also electronic company. I don't know this one. Honghai is also electronics. This one, Taijidian, is TSMC. This is a semiconductor company. Ruiyu, this is an LED company. Hetaiche, this is a car company. Lianyang, I don't know, maybe it should be electronics. You will see the top 10 company give the highest salary in Taiwan. Maybe more than 50% are related to electronics. As long as it cover it with electronics in Taiwan, they will hire chemical engineer because they want to manufacture the chips. And chemical engineer actually is an engineer can do the chemical process when fabrication the chips. And this is the annual salary for the top one. You see the number and the units is 10,000. So the first one is about 3.8 million Taiwan dollars. So it's about 100,000 USD dollar. About 100,000 USD dollar. Okay, the first one. Yeah, and Taijidian actually is the very popular company in Taiwan. So you see the price there. Yeah. Okay, we take a 10 minutes break, okay? Then we'll come back for the discussion. So let's continue. The second class of this sharing, again, I will say this is sharing for today. So we will focus more on how I can understand myself should choose chemi or not. So now you probably understand what's chemical engineering and some simple and basic concept. Although you don't take any class related to chemi, but at least now you know the mission of chemical engineering is try to make revenue, making money by designing chemical engineering process. In this process, we convert low price things into high value add products. And chemi is everywhere. As I mentioned, you can find a lot of jobs, depends on your interest. And the salary is high in Taiwan, not only in Taiwan, in the United States, around the world. Chemi salary, I will not say the top one, but at least in the top ranking. So maybe now we should discuss There are so many wonderful things about Chem E, but should I choose Chem E? So I summarize in the past 20 years, including my personal experience. So I was a college in Chem E major, and now I'm the professor in Chemical Engineering department. In the past 20 years, I summarize some common reasons why people choose Chem E. And maybe it's one of your reasons you want to consider Chem E. And the point is I want to break up your imagination of Chem E by giving you my sincere comment. Maybe this factor are not a good reason to choose Chem E. First, maybe some of you want to choose Chem E because I like chemistry. If this is your only one reason you want to choose Chem E, no, don't do that. Because Chem E will not focus on chemistry a lot. In your college life, 4-year chemical engineering study, maybe only 10 to 20% are covering chemistry, including biochemistry, organic chemistry, physical chemistry, quantum chemistry. Only 10 to 20%, which means that in your 4 years college study, only 10 to 20% are studying chemistry. The other 80%, half of the 80%, which is 40%, are mathematics. The other 40% are physics. So think about the whole circle. Totally 100% and only 10 to 20% of your study focus on chemistry. And the other 40% is mathematics, calculus, then engineering mathematics, partial equation, differential equation, Laplace transform. You don't even understand what I'm talking about because they are very difficult mathematics equations. And the other 40% will be physics, including general physics, mechanics, thermodynamics, kinetics, fluid mechanics, heat transfer, energy transfer, mass transfer. And the reason why we need to study a lot of physics and mathematics, because, as I mentioned, we want to design process. We want to design process to promote this chemical reaction. From here to here is chemical reaction, but how to promote so that we can make it revenue and minimize the cost. We need to design this process. And actually, how to promote the chemical reaction is by physical method. Physics is the hand to accelerate the chemical reaction. All the factor to promote the chemical reaction is by physical ways. The reason is that think about a simple chemistry. A plus B becomes C. You have molecule A and molecule B, they meet together. By right condition, they will convert to molecule C. But how to promote them to meet each other is by physical collision. Right? When A have a collision with B, they can break the bond and form new bonds, chemical bonds, then C. So this very fundamental behavior actually is related to physics. So we need to study a lot of physics, mechanics, fluid mechanics, heat transfer, energy transfer, mass transfer, all kinds of way by physics to promote the chemical reaction. Chemical reaction is a result. However, the reason, the factor to control the chemical reaction is by physical way. So we need to study a lot of physics. Okay? Right? And why we need to study a lot of math? because math is the language to understand physics. Simple, right? So you need to study a lot of physics. No wonder you need to study a lot of mathematics. By understanding the mathematics and physics, then you can design the process to promote a chemical reaction. So in short, if your reason to choose chemi is because I like chemistry. Professor, I like chemistry, so I want to choose chemi as my major. Well, don't do that. Is that your voice in your heart because you like chemistry? Okay, so I see a lot of people, a lot of young students, they choose chemi, the reason because they like chemistry. And once they choose chemi as a chemistry, they realize why there are so less class, so less portion on chemistry, and instead of that, a lot of physics, a lot of mathematics. Some students, they want to have engineering major, but they don't like physics, they don't like mathematics. So they say, oh, I should go to chemi because there should be less physics and less mathematics. Sorry. Don't choose chemi. Okay, maybe this is the reason you want to. So, but maybe your question is that I do like chemistry, but I want to have the engineering major. What should I do? You want to know my sincere answer for you is that you should choose the chemistry as your major because you like chemistry. You like this girl, but you say I want to choose a girl nearby. It doesn't make sense, right? You like chemistry, then you should choose chemistry as your major. Why you choose engineering major? And you told me that you like chemistry, right? If you do like chemistry, then you should change your major to chemistry. But if you really want to have an engineering degree, then probably chemi is the engineering subject most close to chemistry in the whole college of engineering compared to EE and ME. Because compared to ME and EE, there's almost no chemistry. But at least you choose chemi, you have 10 to 20% of chemistry. Okay, so that's the first reason a lot of students, they choose chemi because they say they like chemistry. Okay. And 2 and 3 is very straightforward. Students choose chemi because chemi, after you have the degree of chemi, you can find job easily. Yes, in Taiwan, yes. And I think also in other countries, if you have the major in chemi, you can find job more easily compared to other major. But that will depend on the profile of the industry of the country you want to working on. But in Taiwan, yes, chemi you can find job easily. You can go to petroleum, you can go to all kinds of material engineering process, and also the semiconductor. And yes, if you have a major in chemi, you can get high salary. As I already shared, in Taiwan, we have a lot of portion as semiconductor. Yeah, so you can find high salary job using a chemical engineering major. Number 4, I see a lot of students. I have no preference because my point is so high, so I can go to chemi. I don't want to choose anything, just my points are right. In Taiwan, in engineering degree, the student with the topest score, they will go to EE and computer science, and then they will choose chemi or material engineering. Then they will go to mechanical engineering, then civil engineering or construction. So chemi students usually they have quite top score in school. So I see some students, they don't have any reason because their point is high enough, so they choose chemi. Maybe this is some of the reason for me. Number 5, I see some students, I don't have any preference, but my parents, my family asked me to choose chemi, so I choose. Don't think I'm kidding, but in Taiwan, a lot of students, they don't have their own opinion or preference. Sometimes they just follow the goal from their families. So this could be your reason. And number 6, some students, they like challenge. It's because chemi major in college has a lot of homework loading compared to EE and ME because besides physics and mathematics, chemistry students need to take additional chemistry class. So the working loading and the homework and examination in chemistry major student usually is more than the major double in mechanical engineering. Okay, because double in mechanical engineering they focus on physics and mathematics. They almost no study on chemistry, but chemistry students need to study more chemistry. So the workloading is heavier than other major in engineering college. So some students like pressure, they like challenge. I don't know why. So they choose chemistry. And maybe others. Others depends on someone I love choose chemistry, so I follow him or her. That's a very common reason for teenagers. Or the reason is that in the whole engineering college, chemistry department has more goal compared to department of double E and mechanical engineering. So some guys they go to chemistry because the classroom with more goal will be more fun. So that could be another reason. Others, why students choose chemistry as a major. Okay, so this is just some sharing about possible factor you want to choose chemistry. Okay, right. So any question regarding chemistry, or you want to ask me my comments? If you have some puzzle or consideration about chemical engineering, can I do some investigation? How many of you want to choose chemistry as your major right now? Yeah. Pretty good. Yeah. So is this belong to the reason you choose chemistry? Yeah. Which one? Number 3. Okay. Not one. No. You like? Okay.
I think nobody likes chemistry.
Okay. How about you girls? How about your reason? Yeah, you. 3? Okay. Yeah. Good choice. Not because of me. If you choose, you will see me very often in the classroom. Okay. All right. Okay. So I want to show the website. Okay. If you go to this is a website of our Department of Chemical Engineering. So you will see something checking, for example, the goal. Yeah, sometimes it's very long, but I didn't check. I just want to tell you some information about the faculty. You can go to the faculty and check their profile, and maybe you will find some interesting topic you are interested in, because in our department we ask you to do special projects for your graduation. So if you need to do your special project, you need to choose a lab and choose a professor as your supervisor. So maybe now is a good time you can, if you want to choose chemistry as your major, you can sometimes you come here and serving the information. Yeah, that's me. I do carbon nanomaterial synthesis and application, and microplasma technology and application. I don't have time to talk about this, but if you are interested on this, we can send me email. If you double click here, you can get my email. It's my phone number. Or if you want, we can add line after the talk today. Then we can have the meeting to discuss. Okay, I'm looking for some students who want to do special project. We focus on material and plastic. All right, so you can also find other professor to find some interesting topic you want to work on a special project. Okay. Yeah, basically that's everything I want to share. So the rest of the time, I want to do Q&A to answer some of your questions. You guys have some questions? No? Any question? Yeah. You can use Chinese if you want. 好啊。 she's asking me about the homework loading. Is that really, really heavy? And she's asking me by when I can go to bed. It depends on your skill and your capability. And by 12, 1 is reasonable. If you're smart, maybe 10, 11. If you are a little bit lower than average, maybe 1, 2. But I think that depends on your attitude. If your attitude is good, maybe you can push you up. So, 我的回答就是说，功课是很重，但是看你的求学态度跟你的能力。我有看过很多学生，他也是就是11点、12点就睡觉，但是也有很多学生会熬夜熬到1、2点、3、4点。但我觉得跟读书方法有关，就是你熬夜熬得久，不代表你成绩就会比较好；你很早去睡觉，也不代表你成绩会不好。你。写作业写到1、2点应该是很正常的事情吧。So she's asked me, is that normal to prepare the homework every day until 1, 2 a.m.? I think it's quite normal. Because from 8 a.m. to 5 p.m. you taking class. Then you will start to study, review, and prepare your homework. So until midnight, I think it's reasonable for every day for Chemistry major students. But I would say is that if you have a group of students, you are not working alone. Then if you have a journal club together, then everybody can help each other and have the discussion. Because sometimes when you prepare homework, taking you a long time because you need to digest the class material first and read the textbook so that you can understand the material. Then you can prepare the homework. Sometimes you want to write homework. I was a student before. I know I want to write the homework, but if I don't understand how to answer, how I can prepare the homework. So to understand how to answer the homework, I need to digest the class material and read the textbook, and give me some time to understand so that I have the capability to answer the homework. That's very, very long-term training. It will not be easy. I take a class in the morning, then suddenly I understand everything 100%, then I can do the homework, right? So I think the reason is that there are so many things you need to study every day, and you only have limited time. So prepare homework by 1 midnight, I think it's reasonable. 因为你要修的课实在太多，我觉得我的感觉是化工系的学生要修的课太多了。你每天都在上课，可是上完课之后，你还要去消化、吸收、理解，你才能写作业、准备考试。如果你是很正常的学生，我所谓很正常的学生，就是都有去上课、有去修课。然后修完课、上完课之后回家开始念书的话，如果你是这种正常的学生的话，每天1、2点睡觉是很正常的事情。这种岁月会持续到你毕业。那如果你是不正常的学生，不正常的学生就有2种，一个就是天资特别好，老师随便讲就懂了，然后你也不用看，你就写作业，然后也会考试，这种学生也是有。另外一种不正常的学生，就是老师不管怎么教，他都不去念。然后不管怎样，他就是不去准备作业，这样一直被当学生也是有。但是我觉得那个正常分布底下，正常的那个中间的学生，每天1、2点睡觉是蛮正常的。这样不知道有没有回答你的问题？But I think no pain, no gain, right? So you want to get high salary and find job easily. You need to pay your time, right? No pain, no gain. The worst, the fair. There's no free lunch. You spend very stressed and very intense 4 years in chemistry, and after you graduate, you get a chemistry degree, 2 or 3. That's the point I think is realized. So it's fair. Yeah. 还有没有其他问题关于化工系？那很多 maybe some of you will ask me what's the difference between chemistry and materials engineering, right? These things overlap a lot. So what's the major difference between chemical engineering and materials engineering? I would say materials engineering, they more focus on solid material. But chemical engineering, not only solid material, we also focus on gas material, and liquid material. So we know material has 3 states, right? Gas phase, liquid phase, and solid phase. Material engineering, they pay special attention on solid things. But chemistry is more broad. Anything can be produced by chemistry reaction, whatever they face, including gas phase, liquid phase, and solid phase. We all deal with that. The material engineering, they more focus on solid. For example, metals and thin films. So they more focus on solid material. 我觉得材料系跟化工系最大的差别就是材料系他们处理的物体，最主要是固体的材料，比如说金属表面啊，或是陶瓷表面，或者是这种薄膜型的。但是化工的话，就是物质有3态嘛，不光是这个固体表面，就是各种材料，液体的、气体的，也是在我们合成跟探讨的范围。And material engineering more focus on semiconductor because they focus on solid material. And semiconductor actually is a product of solid state physics. So they more focus on semiconductor. But for chemistry, we go beyond of semiconductor. We also extend to pharmaceutical, petroleum, and other area which is not a conventional area for materials engineering. Yeah. So which means that the workloading of material engineering will be less than the workloading of chemical engineering because they only focus on solid material. 材料系一般的课就没有化工系那么重，所以你可以考虑材料系。So some students they will consider materials engineering if they want to produce something, they want to learn how to produce, but they don't want to have so intense college life, they will consider materials engineering. Okay? But I think it really depends on what you want. Other questions? 你们还有问题吗？
有什么可以比较好学物理的方法吗？
He's asking me what's the best way to learn physics. No. There's no
way.
There's no such way. If I know, I will go to Bushiban. I will teach you. There's no such way to learn physics. I think how to learn all the subjects, not limited to physics, is that you need to understand the fundamental. You need to understand the reason why we studied this and what's the fundamental. Instead of looking a lot of mathematics equation. Because I think for college students, sometimes you feel puzzled. Why I don't understand such things? Because when professor show a lot of mathematical equation on the board, you're shocked. Wow, so many mathematics. Then you force yourself try to understand the mathematics. The mathematics is just the tool to understand the physics. You should go back to the original point of this physics. For example, when professor talking about some physical phenomenon, for example, speed, optics, you should focus on the fundamental. What's going on here? And what's a fundamental factor during this physical phenomenon? Once you're understanding the reason and the motivation why we want to talk about this physics, then next step is using mathematical equation to understanding the fundamental of physics. But a lot of students, they go to the other way, try to understand the physics, try to understanding the mathematics first, but their capability of mathematics is not so great, so they get lost in a lot of equation. And once they get lost, they lose the passion to understand the physics phenomenon. Yeah, I think that's very wrong way to understand the physics. You should focus on the physics. So why, for example, for Newton, why? For example, think about your Newton for 100 years ago when you falling attacked by the apple. I think the first thought from the Newton is that, oh, F equal to ma. No, right? That's not the first thought from Newton. His first thought, well, why I will be hit by apple? Is there any special force to grab the apple to hit my head? Then he start to think about the fundamental, what's going on. Then once he understands what's going on, find a pattern, then he need to understand the phenomenon. So he need a tool using mathematics. Then summarize and conclude that you can using a simple formula F equal to ma to describe this, right? So think about you on Newton. You are now focused on F equal ma first, right? Yeah. 所以我觉得学物理的话，应该是不要马上就去了解数学，因为很多同学学物理，包括我自己啊，我自己物理也不是太好。我当初学物理，会觉得物理很难的原因，是因为看到很多不了解的数学，就一头想要去解数学。可是当自己数学能力没有很好去了解这些数学的时候，又忽略了这些物理现象的本质，想要讨论的是什么，然后就会失去耐心，然后就渐渐的就不太了解这个物理在讲什么。我觉得应该学物理，应该是在先了解这个物理现象的本身，它的本质是什么，我们想要讨论的是什么。当你了解到这个缘由之后，你想要更深一层的了解这个物理现象的时候，才需要数学工具来帮助你去了解。我觉得这个步骤应该是比较合理的。So back to your question, what's the best way to learn physics? Maybe next time we should bring the physical professor to share the concept. But I think for at least according to my past learning experience, yeah, we should focus on the physics phenomenon first. We should understand the motivation first, instead of just solving the mathematics without knowing the reason why. Okay? 我希望最后回答到你的问题，因为我不是学物理专业。But I think his question is very important because I mentioned Kenny was dealing with a lot of physics. So maybe he is wondering if I'm not good at physics, should I choose Kenny? That's a good question. If you're really not good at math and you are not really good at physics, maybe you should not choose engineering major. That's back to a very fundamental original question. Engineering actually is applied physics. You guys know the term of engineering? Engineering means that we want to create something, and using that something you create to solve the problem in human society. So for EE, they want to create some circuits. For mechanical engineering people, they want to create some machines, cars, to solve some problem. In ChemE, we want to design some process to solve the mass production process. So all the engineering is around how to solve the problem. And physics is a subject to describe all the problems happening every day. So engineering actually is applied physics phenomenon to solve human society problems. So I would say engineering actually is applied physics. But just focus on chemical reaction using applied physics to solve the chemical reaction problem, that will be ChemE, chemical engineering. Using applied physics to solve the circuits, electronics problem, that will be EE. Using applied physics to solve the machine problem, that will be mechanical engineering. All the engineering subjects are focused on applied physics. So if you are not good at physics, you are not good at math, you still can choose engineering subject, but that will be tough because that's the key of engineering. Physics is the key. Physics is the key of engineering, and math is the key to understanding physics. Do you guys know there are very good saying from Isaac Newton? Newton says, Newton says, the God, everybody know God? God?
Yeah.
God has two hands, left hands and right hands. Newton says the left hand of God is physics, and the right hand is mathematics. So God with the left hand and right hand, which is physics and mathematics, he can describe the world. So physics used to describe all the activity, all the phenomena around the world, and math is a way to describe the physics. So, yeah, that's a very good saying from Newton. So I just quote this for you. Okay, if you want to understand the world, understand physics is a key, right? Okay, so if you don't have any questions, we should have happy hour for Friday, right? I think it's a good timing. We don't have to stay here until the last minute. So if you have questions about the talk today, you are shy to ask on public, you can come to me. We can discuss. And if you want, you can go to the website and you can find my email. Yeah, my email. Let me copy that. And you can write me email if you want. Oh, I have email here. So this is my email. So if you have questions regarding Kenny, you want to discuss, you can write me email. We can set up an appointment. We can discuss in my office. All right. Okay. Everybody happy? Yeah. See you guys. Hopefully next time see you in Kenny department. Thank you.